Welcome to yet another session of Everyday Mathematics. Here at Everyday Mathematics, we say that we do enjoy solving the harder problems, but above that, we also see and appreciate the beauty in the simpler problems. So today we are yet still at the MIT 2022 Integration B qualifying exams, still focusing on the topic of polynomials. We shift from the first part to the second part. And today we'll look at mainly three problems in this part. So the first problem will be problem number 13 in the qualifying exam of the 2022 Integration B, which is the integral of x to the power 3, over 1 plus x squared over 2 plus x cubed over 6. This is an indefinite integral, so it has no limits. The next problem is problem 18, which is the integration of 1 over square root of x minus x squared. Now this is also an indefinite integral, so we have no limits. In the last problem is problem number 19, and this is the harder problem in this problem set, which is the integration from x equals to 0 to x equals to a half of the summation of this binomial coefficient of n plus 3 and n times x to the power n. And this is from n equals to 0 to n equals to infinity. So before we jump onto the solutions to these problems, I would like to really thank our subscribers. Thank you so much for the greater support that you continue to bestow to us. We don't take it for granted. We are really grateful. For our first-time visitors, we really would use your support. Please just spare a moment and subscribe to our channel. If you're here for the second or third time and you haven't subscribed, we do encourage you. We'll need your support, and really your support will take us farther than you can imagine. Thank you so much, and now we'll jump into the solution bit. So problem 13, the integration, indefinite integral of x to the power 3 over 1 plus x squared over 2 plus x cubed over 6. The first thing I'll do is to simplify this into a mixed fraction because obviously the numerator is of the same degree as the denominator, so we'd want to convert it to a proper fraction. And the first thing I'll do is just go along the long division approach. We have x to the power 3 in here, and then we divide that by 1 plus x squared over 2 plus x cubed over 6. So we'd have to multiply that divisor by 6 so that we have the same constant for the highest degree here. And so when we subtract x cubed plus 3x squared plus 6x plus 6, we get negative 3x squared minus 6x minus 6. So essentially what that means is x cubed over 1 plus x squared over 2 plus x cubed over 6 is equals to this 6 minus, I've decided to pull the negative out, 3x squared plus 6x plus 6 over 1 plus x squared over 2 plus x squared over 3. So pulling 6 out, we have now x squared over 2 plus x plus 1. And this here is just the derivative of the denominator. So that when we plug that back as our integrand, we can simply integrate 6 and then minus 6. And since this is a derivative of the denominator, we can now take advantage of the natural logarithm function, whose derivative is the derivative of the function within the log function over that same function. So essentially, our integral or the integration is 6x minus 6 natural logarithm of 1 plus x squared over 2 plus x cubed over 6 plus this integration constant. And that is the solution to this problem. It was the simplest problem, and this problem kind of keep on increasing in difficulty as we go further. So problem 18, the integration of 1 over square root of x minus x squared. So I would first of all pull out the square root of x so that we have in the denominator the product of square root of x and the square root of 1 minus x. Now, the next thing I'll do is I'll say let u be equal to square root of x such that du dx is 1 over 2 root x, which means that du dx is equals to 1 over 2u. And so multiplying both sides by 2u, 2u du is equals to dx. So we can substitute for root x with u. So we have 1 over u times square root of 1 minus u squared times 2u du. And that is 2u du is in place of dx. So this is 2. The u cancel, the u in the numerator and the denominator cancel. So we have now 2 times the integration of 1 over square root of 1 minus u squared. And so we can now say let u be equal to sine theta. And so du d theta is equal to cosine theta. And so du is equal to cosine theta d theta. So the integration to integral of 1 over square root of 1 minus u squared du is equal to 2 the integration of 1 over square root of 1 minus sine squared theta times cosine theta d cosine theta. And so that means that the denominator now decreases to square root of cosine squared theta, and the square root of cosine squared theta is cosine theta. So since the denominator and the numerator are the same, we just simply have the integration of theta, or integration of 1. And so we have 2 theta plus c. And since we say that u is equal to sine theta, what that means is that theta is equal to arc sine of u. And so the intermediate integration there is 2 arc sine u plus the integration constant c. Now, since u is equal to square root of x, then the final integration of 1 over square root of x minus x squared is equal to 2 arc sine of square root of x plus our integration constant. And that is the answer for this problem. So these first 2 problems we've looked at today are pretty manageable and easy to handle. I think the third problem that we're going to be looking at will be the one that will be more involving, which is the integration of from x equals to 0 to x equals to a half of the summation from n equals to 0 to infinity of the binomial coefficient n plus 3 n times x to the power n. So this problem, first of all, I think what we could do is express the binomial coefficient in a way that is easy to understand. So this is the same as there's an error here. So what we can do is we can correct that. So instead of n plus 1, it's n plus 3. So n plus 3 factorial over n factorial over n plus 3 minus this n factorial. So that's the binomial coefficient simplified. And so still focusing on the binomial coefficient, what happens is then that n plus 3 factorial obviously would mean that values of n and below would cancel out with what we have in the denominator. And since n plus 3 minus n is just 3 factorial, we are left with, in the numerator, n plus 3, n plus 1 times n plus 1, n plus 2 times n plus 1. And then the n factorial disappears. And then in the denominator, we have 3 factorial. 3 factorial is 6. So we do have 1 over 6 here times n plus 3 times n plus 2 times n plus 1 times x to the power n. And then we can pull out that constant completely. And so we are left with the n's under the summation sign. We can then transport the integration sign into the summation sign. And so focusing on the x to the power n term, when we integrate that, it means that now we have n plus 3 times n plus 2 plus n plus 1 over n plus 1, and then x to the power n plus 1, and then we have the limit 0 and a half. So going forward, the n plus 1 cancels the n plus 1 in the denominator. And so we are left with the summation. 6 times the summation from n is equal to 0 to infinity of n plus 3 times n plus 2 times half to the power n plus 1. Now we can simplify the half to the power n plus 1 by taking one of the halves out, so that we have 1 over 12 times the summation of n plus 3, n plus 2 from n is equal to 0 to infinity, and this again times a half to the power n. So this becomes a little bit dicey. We can multiply the two constants here. So we have n squared plus 5n plus 6, right? So we can separate this into 3 separate summations. We can sum it, we can take it as 1 over 12 as summation of n squared times a half the power n, 5 over 12 times the summation of n times a half to the power n, plus 6 over 12 times the summation of half to the power n. So we've color coded this. So we have the purple to indicate n squared times a half to the power n, summed from 0 to infinity, and green denoting 5 times over 12 times the summation of n times a half to the power n, and from 0 to infinity. And then the bright blue is half times just the summation of half to the power n from n is equals to 0 to infinity. So beginning with the simpler summation, half times the summation of half the power n from n is equals to 0 to infinity. This is a typical geometrical progression problem. And so we have 1 plus half squared plus half the power 3, and so on. And since we know that the summation of r to the power n from n is equal to 0 to infinity, where r is our common ratio, is 1 over 1 minus that common ratio r. So in brackets here, we have the initial term 1 over 1 minus the common ratio half times a half outside. So this is a half times 1 over half. And so this is a half times 2, which is equals to 1. So the summation indicated by blue is 1. Then the summation indicated by green, which is 5 over 12 times the summation of n times half to the power n from n is equals to 0 to infinity, is 5 times 12 over 12 times in bracket 1 times half plus 2 times half the power 2 plus 3 times half the power 3, and so on. So to really make this clear, let's take the sum of 1 plus r plus 2 times r to the power 2 plus 3 times r to the power 3 as S1. Take that sum to be S1. And this is a unique sum where we have, for every term in the summation series, we have a product of n and the common ratio. So if we multiply the common ratio by S1, then we have this same series, but staggered. Only that now we have 1 times r to the power 2 plus 2 times r to the power 3, and so on. So when you get the difference of s1 minus rs1, you get now 1 times r plus 1 times r squared plus 1 times r cubed. And as you can see, this is the same as r plus r squared plus r cubed. This is the geometrical progression problem, but with the initial term as r. So s1 minus rs1 is r over 1 minus r. And so s1 is the same as r divided by 1 minus r squared. So we can use that formula, and now 5 over 12 summation of n times n to the power n from n equals to 0 to infinity is 5 over 12 times now r, which is a half, minus 1 minus half, which is our r, squared. And so that means we have 5 over 12 times 1 over 2. 1 minus a half is a half, squared is a quarter. So a half divided by a quarter is 2. And so 5 over 12 times 2 is 5 over 6. So the green term sums up to 5 over 6. And then the purple term, which is the more complex one, which is a half 1 over 12 times the summation of n squared times a half to the power n, which is it's the same as 1 over 12 times into bracket 1 times a half plus 2 squared times 1 over 2 squared plus 3 squared times 1 over 2 to the power 3 or cubed, and so on. So if we take the sum of n squared times a common ratio, r to the power n as s2, and then we multiply r by s2, we have this same series but staggered in such a way that 1 is now multiplied by r to the power 2, and 2 squared multiplied by r to the power 3. So when you subtract these, we have 1 times r minus 0 is 1 plus 1 times r. 2 squared minus 1 is the same as 2 minus 1 times 2 plus 1, the product of the difference and the sum. And so we have 3 r squared there, and then 3 squared minus 2 squared is the same as 3 minus 2 plus 3 times 3 plus 2, which is 5. So 5 times r cubed, and so on. So as we look at this problem, we can express it as the sum of 3 is the same as 2 plus 1, and then 5 is the same as 3 plus 2. And so what this essentially means is that the difference between S2 and RS2 is 1 times R times 2 times R squared plus 3 times R cubed plus R 1 times R plus 2 times R squared, where this here is similar to the sum S1 we computed previously. So S2 minus RS2 is the same as S1 plus RS1. And so S2 minus RS2, we said is S1 plus RS1. So factoring out, we have S2 in bracket 1 minus R is equals to S1 plus RS1. And so S2 is S1, we factor out that, times 1 plus R divided by 1 minus R. So we know S1 to be R over 1 minus R squared. So R divided by 1 minus R squared times 1 plus R over 1 minus R. This is equal to S2. So our final value for S2 is R times 1 plus R over 1 minus R cubed. So our problem, 1 over 12 times the summation of n squared times 1 over 2 to the power n is 1 over 12 times r is a half times 1 plus a half over 1 minus a half cubed, which is 1 over 12, a half over 3 over 2 divided by a half cubed, which is 1 over 8. So 1 over 12 times 3/4 divided by 1 over 8 is the same as 1 over 12 times 3 times 2, which is 6 over 12, which is equals to a half. So our integration, which is a little bit more complex, is the purple plus the green plus the blue. And the purple has been found to be a half. So a half, the green was found to be 5 over 6, and the blue was found to be 1. So adding those things up, we get 3 plus 5 plus 6 over 6, and that is 14 over 6, which is 7 over 3. And that is our final answer. It's a little bit more complex and more is brain taxing, but very, very interesting problem. Thank you again for hanging out with us while we solve this problem. It's been a real pleasure hanging out with you. Until next time, tout à l'heure à la prochaine fois. Adios. Thank you.